So, today our warm-up says an arithmetic sequence that in an arithmetic sequence, we know that the 8th term is 38, the 11th term is 77. What are the 9th and the 10th terms? In other words, what are the ones in between? And I gave you a hint. This one's the 8th. This one's the 8th, this one's the 11th. How do we go from term to term in an arithmetic sequence? Oh, come on, we just said this. How do we go from here to here? Add whatever D is. Once I gave you that hint, how did you go about attempting this problem? That is one option of how to do it. You have a formula for the arithmetic sequence. You can plug things in. So a sub n equals a sub 1 plus n minus 1 times d. Now there's a couple of different ways on how you can do this. So the question is, if you chose to plug it into the equation, how did you choose to do that? You could just tell me what you actually wrote down, if that's easier.
So 8 minus 1 is 7 times d, and a1 plus that is 38.
So this is 38. Okay.
The same thing for the other one.
And you did the same thing for the other one. 77 equals a sub 1 plus, this time it was the 11th term, and 11 minus 1 was 10 times d. So essentially, if you missed it, this was from when it was 8 minus 1, and this was from when it was 11 minus 1. Doing this gets you a system of equations in two variables. Can we solve a system of equations? You should be able to. If it's easier to look at, your system of equations that we have right now is almost like a 38 equals x plus 7d, and 77 equals x plus 10d. Do you notice that the x's both have the same coefficient? So I can multiply one of the equations by -1. And then if I add my equations, the x's will cancel out. I'll get 3d equals 77 minus 38, 39, and then divide, and we would find that d is 13. Once you know that d is 13, how can you find those missing terms? Add 13. How to go from term to term? You add 13 every time. This one would end up being 51. This one would end up being 64. I am guessing most of you did not do it that way. No. It is a fantastic way to do it, and if that is the way that your brain works, great. That is the most traditional way to do it. There are less traditional ways that tend to be faster. Did anyone else get 51 and 64 a different way? Ellie, how'd you do it? Guess and check. That is definitely a possibility. Do you want to guess and check if it has the possibility of being decimals? Nah, it's probably not the best option. Is there another method that people use that was not guess and check or this? Curiosity, how'd you do it?
I took 77 minus 38, got whatever that was, and then divided it by 3 because you moved 3 spots.
We added D 3 times to get from the first term to the last term. So that means that 38 plus D plus D plus D equals 77. Now, I highly doubt she did it this formally. I wouldn't expect as much. But essentially, you can say that this is true. Minus 38, 3D equals 39, D is 13 again. Essentially, what the less formal version of what she actually did is saying adding D 3 times was equivalent of going from 38 to 77. To go from 38 to 77, you had to add 39. That 39 is split amongst 3. 39 divided by 3, 13. So, there are actually a lot of different ways to do problems like this. I will show you an additional way to do it in notes today. Which way you do it is the way that works best for you. I highly recommend guess and check is not your best option. So today we're talking about arithmetic means, and arithmetic means are the numbers that happen in the meantime between two numbers in a list. It's what we were actually just doing in the warm-up. It's missing terms between two non-consecutive terms in a sequence. Specifically, in this case, an arithmetic sequence. If it was geometric, they'd be called geometric means. So if I have a bunch of terms in a sequence, I know that that one's 2, I know that this one's 48. How long are sequences, by the way? When does a sequence stop? It doesn't, which means how long are they? Infinitely long. They go on forever. But these right here would be our arithmetic means. At least between 2 and 48 in this particular list. Now, generally speaking, when it comes to working with our arithmetic means, you are not going to be told this number is the 8th term in the sequence and this number is the 11th term. All you're going to be told is the two numbers are in the list. How are you going to be told that? Commonly, you're going to be told to find the 3 arithmetic means between 21 and 45. Now, when you are asked to find arithmetic means, or eventually we're going to do geometric means as well, the first thing I do recommend that people write out, even though it is not a requirement, is write out what you know of the sequence, including blanks, because that gives a big visual of how to get from one place to the other. So 21's on the list, and there are 3 blanks between it and 45. Now you can use any of the methods that we did in the warm-up if you wish. They will work just fine. But oftentimes, I just use the formula to my advantage, but I don't use it as a system. I use it as a single formula. We do not know where 21 and 45 are in this list. We just know they're in a list together and that there's 3 numbers between them. If we do not know where they are, we could treat it as if this first term was an a sub 1, which I believe I was asked during this. Can we treat it like the first term? And the answer is yes. And if that is the first term, that is a sub 1, what is this one called? A sub 5. So if a sub 1 is equal to 21, a sub 5 is equal to 45, my formula, a sub n equals a sub 1 plus in parentheses n minus 1 times d, I can treat my a sub 5 as my a sub n. A sub n would be the 45 when n is 5. Remember, these two things must go together when you write it this way. How'd we get n is 5? That's called a sub 5. It's the 5th term. It's that subscript. A sub 1 would be 21, n would be 5, and d is the missing piece. If we knew what d was, we could easily fill in the terms, because to go from term to term in an arithmetic sequence, we add d. I could solve this equation. Where do I start in solving this equation? Please do not distribute. Can you? Yes. Will it work? Absolutely. Is it a lot of extra work? Well, maybe not a lot, but can't I just do 5 minus 1? 45 equals 21 plus 4 times d. In other words, 4d. Minus 21. I get 24 equals 4d, therefore d is 6. Now be careful, is d what we actually wanted in the problem? Is it what the question asks for? No, it asks for the arithmetic means. It asks for what these 3 numbers are. Once I know it's 6, to get from here to here, add 6. What's 21 plus 6? To get from here to here, add 6. 33. To get from here to here, add 6. 39. How can I check that I did it right? Add 6. Do you get 45? Sweet, we did it right. These 3 numbers are my answer, 27, 33, 39, in that order. Could you have done it a shorter way? Yeah. You can do it the less formal way, the way that Julie had done, where she recognized if these 2 numbers are in the list, the change from 21 to 45 is a whole 24, and we got there by adding d 1, 2, 3, 4 times. 24 divided by 4, 6. If that doesn't make sense to you, do it this way. I write too big. Try that one out on your own. Why is this in here? Oops. Okay. Overall, I'm seeing a lot of different ways that people are doing it. Whichever way made the most sense to you, I am perfectly fine with that, except for, which one? Guess and check. Now, one of the things that when it comes to this problem, I tell you the numbers in the list are 36 and negative 18. Do I tell you what order they go in? No, because it doesn't matter. Which would probably be easiest, smallest to biggest or biggest to smallest? Would it be easier to put the numbers in order from small to big or from big to small? Generally, we do smallest to biggest if we get to choose. My point being, if you chose to write it out 36 blank, 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 negative 18, beautiful. If you chose to write it out negative 18, 1, 2, 3, 4, 5, 36, either way should get you the exact same geometric means. The difference will be if D is positive or if D is negative. Now, if you do this the traditional way, the first term is called A sub 1. What is your last term? A sub 7. That is why I recommend you write this out. Because people tend to call it A sub 5 when there's 5 geometric means, or A sub 6 when there's 5 geometric means. There's justification as to why I understand they do both, but this is A sub 7. So if I do it this way, 36 equals negative 18 plus 7 minus 1 times D. I go through the process, this would give me D is equal to a positive 9. If you did it this way, D would be negative 9. In the end, your geometric means are 27, 18, 9, 0, negative 9, or negative 9, 0, 9, 18, 27. Only other thing you're going to see a little bit of today. Find the first 5 terms, and then it'll give you an equation. My hint to you is, what do you call the first 5 terms? What are their names? A sub 1, A sub 2, A sub 3, A sub 4, A sub 5. I give you that hint because that tells you exactly what to do to find it. If I want A sub 1, that's telling me n is equal to 1. If I want A sub 2, that's telling me what? 2 times 1 plus 6.
2 times 2 plus 6.
It's telling me n is 2 if I want A sub 2. If I want to find the third term, what do I do? Plug 3 in, n is 3. After a while, can't you see the pattern happening? This sequence is starting at 8, adding 2 every time. Now I can continue to plug in 4 and plug in 5, but what numbers am I going to get? Add 2, add 2, add 2, add 2. Seem doable?